Welcome to a lesson with Dr. Powell. Let's take a look at the pigeonhole principle. The pigeonhole principle is really nice to see with fiber box diagrams of functions. So let's suppose we have a fiber box diagram. These would represent different fibers. And let's suppose we have different codomain elements, A, B, C, and D. Now, the pigeonhole principle idea is an idea of forcing a function to not be injective. That is, how large does the domain have to be in order for the function to not be injective? Remember what injective means? Injective means that that you have no more than one element in a fiber box. You could have 0 elements in a fiber box or 1 element, but no more for it to be injective. So to force it to not be injective means that you're forcing things to be in the box, more than one thing to be in each box. Well, if your only criterion is just the size of domain, let's see, well, there's 4 boxes. Worst case scenario, if you have 4 things, is in terms of injectivity would be, well, you can put 1 thing in each box. So you have 1 thing here, 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 and here. Now, if we have 5 things though, after we put the 4 things in, worst case, then we have to put the other point somewhere else from the domain. Where would it go? It has to go somewhere. So we have forced a merge in our function where 2 things actually travel to the same thing, and therefore we have forced it not to be injective, this particular function. I mean, an example of this would be if you have a deck of 52 cards, and there are 4 different shapes that appear on the cards. You can label it as maybe suites. There's 4 different suites. So how many cards do you have to draw in order so that you know that that at least 2 of them will have the same shape? Well, the shape is kind of like the codomain. So either one shape, another one, or this one, or that one, or a suite. So maybe diamonds, hearts, spades, clovers, or something like that. So you have these 4 different options. And well, if you pull 5 cards, worst case is you can have 1 in each. I mean, oftentimes you may draw all of them the same, and that's what we want. We want to show that we have that our particular function will not be injective. So what's the worst case for not showing injective? That would be, well, if I have 5 things, then that's what'll guarantee it. 4 things won't guarantee that it won't be injective, but 5 things will guarantee that at least 2 will share the same shape. Thanks for watching.